Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 42 of Physics 5054. Today we are going to discuss the last topic of this unit, and that is manometer. Today's topic is measuring gas pressure. Very often in physics lab, we need to determine the pressure of the gas. For measurement of pressure of a gas, we are using a special device called manometer. Monometer is a U-tube consists of containing of a column of liquid. Ladies and gentlemen, the manometer consists of a U-tube. This is a U-shaped tube containing a column of liquid. This liquid may be water, mercury, or oil. Any of the liquid can be used. Ladies and gentlemen, when there is no supply of gas is attached to this manometer, the mercury level settle at a common level, because on both sides of the liquid, that is on A and B, only atmospheric pressure is working. From point B there is P naught, that is atmospheric pressure, and here also this is open, not sealed one, just like in the case of mercury barometer. Ladies and gentlemen, because the atmospheric pressure at the same on this side and on this side, so no level will go up or down. They will be settled at a common level. This is shown in this figure number 1. The liquid is shown, which is mercury, and that is due to on red. On red line shows the liquid. Ladies and gentlemen, when the gas supply is attached to the manometer, it means that we want to find the pressure of this gas, that how much pressure this is applying, and we want to measure that. Ladies and gentlemen, when this gas supply is attached to manometer, it will push the uh, column level at point B downward. If the pressure of this gas supply is greater than the atmospheric pressure, on this side only atmospheric pressure is working, while on this side there is a supply. If this pressure is greater than the atmospheric pressure, so this column level will go upward and this column level will go downward, which is shown in this case. The column level at B will move downward because this gas supply will apply a pressure on the upper level, and B level is in this case will move down, and as a result the other side, because atmospheric pressure is less than the gas supply, so this column from A, that A will move upward is shown in this case. Now, if we see that B is in the same level as C and this C is the lowest liquid level because this is in level and this is the movement of the column on the right side and that is ACV are denoting it by H. AC is the height of Mercury which is moved upward when we connected the gas supply to the manometer and this will give you the measurement. So ladies and gentlemen, if we are writing pressure at B, so there will be P naught which is known as atmospheric pressure plus height of column AC, height of column AC. So technically we can write P naught plus rho G H. This equation will give us the pressure at B point. How much pressure is there on the B? What? One is the atmospheric pressure, which is this one. They are in level as I told you this. And the height of the column AAC, which is denoted by H, and this is pressure of the gas, which is rho. Rho shows density of liquid, density of liquid, and G is gravitational force, and H is the height of the column AH, ladies and gentlemen. Okay, that is the whole story, how manometer is working and how we can calculate the pressure of any supply. Now, theoretically we understood that how we can do this, but let us apply this practically. So for practical purpose, there is an example given at 7.6 on page number 108. Let us first understand the question, because understanding the question is half of the solution. Figure 7.21 shows a manometer containing mercury of density rho. So we are taking density of mercury is equal to 13.6 into 10 raised to the power 3 kilogram per meter cube. 3 kilogram per meter cube. That is the first data we are having. Ladies and gentlemen, they are saying connected to a gas supply, which is shown here. This liquid whose density is this one is connected to a gas supply. Calculate the pressure of the gas supply. We have to find PB, pressure at B. It means in the unit centimeter Hg, centimeter of mercury and Pascal. Now you have to understand that we have to find the pressure, this pressure in 2 unit, centimeter of Hg and in Pascal. So we will convert this. Now if you see in the example, take acceleration due to gravity, g is equal to 10 meter per second square. It is also given, and this is also given as this this is 10 raised to the power 3. I told you, but I couldn't record it in written form. You have to do it. It is given in the book. Okay, they are saying that acceleration due to gravity is this. Atmospheric pressure is equal to 76 centimeter of mercury. Ladies and gentlemen, they also given a height of column AC, which is equal to H is equal to 5 centimeter, which is equal to 0.05 meter. So remaining in the context of this data, we have to find by this formula, that is atmospheric pressure, and this is the height of the column AC, which is rho GH. Now pressure at B will be equal to P naught plus height of the column, AC. So we are putting the value 76 plus 5, which is equal to 81 centimeter of Hg. Centimeter of Hg. Hg is a chemical symbol for mercury. Now, ladies and gentlemen, if we want to find the pressure, and that is 81, to convert Hg to Pascal, to convert Hg, centimeter of Hg to Pascal, we will use the formula PB, that will be a subscript, rho G and H. Now ladies and gentlemen, rho is given to us 13.6 into 10 raised to the power 3. 13.6 into 10 raised to the power 3. G value is also given to you, and that is 10, and H is given as 81 centimeter. Yes, it is 81, but we need it in the meter. So cent means 10 raised to the power minus 2 meter. Now all these values we have to calculate by using the calculator, and it comes out to be 1.1 into 10 raised to the power into 10 raised to the power 5 Pascal. We found the value in centimeter Hg, and we also found the value in Pascal. So both the values are founded, and now we are going to start the exercise. Now whatever knowledge you got from this theoretical portion, you have to apply that to practical work. So for that purpose, I have to erase this whiteboard, and then I will come back. Okay, ladies and gentlemen, let us talk about the exercise 7, which is on page number 111, which is single Nelson. Okay, the question number 1 is saying the atmospheric pressure is 100 kilopascal. So P is equal to 100 kilopascal, which is equal to 100 into 10 raised to the power 3 Pascal. That is the first data we are having. What is the force exerted by the atmospheric pressure on a rectangular surface? So we have to find the force, and length of the rectangular surface is given as 0.5 meter, and its breadth is given as 0.4 meter. This is a rectangular surface that measures 0.5 meter by 0.4 meter. Ladies and gentlemen, this is all the data given to us. We know that uh, pressure is equal to force per unit area, and we are going to find pressure and A. So first of all, we have to find the area, and area is equal to 0.5 into 0.4 meter square. When we calculate it, it will be 0.20 meter square. Now we have to put the values inside. This pressure is given as 100 into 10 raised to the power 3, and area we found as 0.2, and that will be Newton. So F is equal to, when we multiplied this 100, so it will be 20 into 10 raised to the power 3 Newton, and we can write it 20 kilo Newton. The force will be exerted, and option A is correct, because that is the answer of option A. In question number 2, they are saying that they given us this figure and saying the diagram below shows a simple mercury barometer at which point is the pressure equal to 10 centimeter Hg below the atmospheric pressure. Now 76 will be Hg, and when we subtract this C point, so it will be 76. So it means C is the correct option. C is the correct option. Now question number 3, they are saying that another one, that what is the length of height of the column of turpentine that would exert the same pressure as 5 centimeter of mercury. Height of mercury, height of, I am writing Hg is equal to 5 centimeter. Yes, it is given as, so density of mercury, that will be H1, and density of mercury, that is Hg, is equal to what? 13,600. 13,600 kilogram per meter cube. And gravitational acceleration G, gravitational acceleration G is given as 9.8 meter per second square. Height of turpentine, we have to find height of turpentine, and that is equal to H2, and we have to find this other piece of information which is given to us, density of turpentine, density of turpentine, and that is rho 2, and that is also given to us as 840 kilogram per meter cube. The last piece of information, density of turpentine, that was density of, is, this is the solution, is pressure of mercury is equal to pressure of mercury is equal to pressure of turpentine. So rho 1 G H1, rho 1 G H1 is equal to rho 2 G H2. G and G will be cancelled, and because we are finding H2, so we will leave H2 on this side. Rho 1 into H1 divide by rho 2. We have to insert the values inside this. 13,600, and H1 is given as 5 centimeter, which is this one, 5 centimeter, and rho 2, which is the density of turpentine, and that is 840. Ladies and gentlemen, when we calculate this, we are getting 80.95, 80.95 centimeter. So in this case, they given us the value 81, which is D. So D is the correct option. That is nearly equal to 81. D is the correct option. Ladies and gentlemen, now we are turning our focus to question number 4. And in question number 4, they given us this diagram. And you have to tell me that the pressure of gas X is more or the pressure of gas Y. It can be clearly seen from the figure because this column is down and this column is up. So it means pressure at gas X is greater. And that is, the question is saying that the diagram below shows a manometer used to compare the pressure of two gases X and Y. What can be deduced about the pressure of the gas X and Y? The first option is the pressure of gas X is greater than that of the gas Y. Yes, it is correct. By 5 millimeter of Hg. So you can see that this is 20 and this is 25. So X, the difference between the two columns is 5. So it means that we don't have to see other option. And option number A is the correct option, because in other, if you check it, they will not be okay. So these were the 4 very important questions of this uh, practical portion. Now there is section B, but because we are running out of time, so let me stop it here, and tomorrow with a cool mind we will start section number B, which is structure question. The first question is saying define pressure, state the SI, which is very easy, but tomorrow we will do inshallah it. Thank you very much for your patience and seeing and remaining with me till the end. Thank you very much. Allah Hafiz.